classes that are a certain size. Okay.
Independence.
It's because we can't really always prove that they're independent from each other, and so we just have enough that it doesn't really change the probability. Okay? Now we have other issues of independence with polling. And that has to do more with people's opinions being formed by the people around them and the question wording and those kinds of things. So we can have some independence issues from that as well. Okay? All right, now, the whole idea you were talking about. Okay? This is my definition of independence, the one Connor was just explaining. Okay? If the definition of this is this. From right over there. Actually, from wherever I erased it. I erased it. If we rewrite this, right? B given A is the probability of A and B divided by the probability of A. Okay. So this probability is the probability of A and B divided by the probability of B. Okay. I just rewrote this using the definition.
Does it matter that
The A's and B's are different?
Yeah.
No, because this one was given A and this one was given B.
shouldn't that make a difference?
I'm just rewriting that formula
For the sake of
for the sake of this one.
Gotcha. Yeah.
I could have used R and Z. It's whatever the given is the bottom. Does that make sense, Jacob?
Yep.
So if you don't like the A's and B's because they're mixing you up with those A's and B's, change them to Z's and H's or something. Okay? I'm going to actually change them to the example in the book because it's the only really good example I've ever heard of how this works. Okay, now, if they are mutually exclusive, this becomes 0. Okay? 0 over anything is
Oh.
0, right?
Yeah.
Unless this didn't have any chance of occurring to start with, I've now changed the probability.
With mutually exclusive.
Yeah, if A and B are mutually exclusive, this cannot be true.
Yeah.
Therefore, they cannot be independent.
Okay.
Okay? Because this becomes 0 if they're mutually exclusive, which means this becomes 0. And unless that had no chance of happening to start with, which would have been a stupid problem, okay, then they cannot, I've changed the probability, A's not equal to 0.
Yeah.
Then they're not independent if they're mutually exclusive. So they can't be both.
Yep.
Okay? The example your book gave is one of the best I've ever heard, because this one, I had a hard time wrapping my head around this for a long time. The whole idea of the probability, I take an adult from the United States population. Probability you're pregnant, probability you're male.
Oh yeah.
Okay?
I forgot about that.
Being pregnant and male are mutually exclusive. At least at this time.
The day's coming.
Yeah, so at least at this time I can still use this example. Okay? So,
Probably
to be a woman.
case soon.
I want to be a woman.
so the probability, okay, of being pregnant, if I took somebody at random, there's a certain probability, I have no idea what it is, it's not huge probably, but there's a reasonable chance I'll get somebody, there's some percentage of the population out there that's pregnant. Okay, so I get some amount that's pregnant. Okay, but the minute I limit myself to the males,
It drops to 0.
it drops to 0.
So they.
So it changes so they cannot be independent of each other, and you know that intuitively. If I'm only picking from males, then it's not independent of being pregnant. Obviously, if you're male, it's going to change the probability of being pregnant. Okay?
Yeah, that makes sense.
So that's why. So they can't be both at the same time. That's a minuscule piece of information, though. It's not something that shows up very often. Just know, if they're mutually exclusive, they can't be independent. Okay? All right. Now, the other thing is the trees. I love trees. Okay. This covers most of the stuff, probably, that's on the test.
Would you say that mutually exclusive, or an event being independent and mutually exclusive is mutually exclusive?
Yes, I think you would.
All
But
right.
don't quote me on that.
Sorry. No.
All right, I'm erasing all of this. Okay.
That's cool. I like the key one.
Okay. One other idea we need that I want to make sure you've got down is, if I ask you for the probability that at least one of something happens, unless it's really small, like 2 things, you don't want to do it forward. You want to work this as a 1 minus the probability of none.
None of that event.
None of that event. Right, I'm going to do an example. Okay? Anytime you see the words at least one, it is so much easier to do it as 1 minus none. Okay. So, here's an example. You're flying a certain route regularly. Let's say you're commuting to another city regularly. The chance that your flight is late, taking off, is 7% of the time. Because if you're flying the same route, then that tends to leave at the same time every day, so you can have some consistency in this. And it's, let's say that 7% of the time this flight runs late. Yes?
So that wouldn't be like considered an independent event, right? Because like if one flight's late, then one of the ones like following it'd be late too.
It would, except for the fact that I'm doing different days on the same flight. So this is the 8 a.m. flight. Every Monday you fly the 8 a.m. flight from here to New York because you work in New York 2 days a week.
Okay.
Cheese and crackers.
Okay? So you take that flight every day. Every Monday you go, you work Monday, Tuesday in New York, you fly home. Okay? So it's the same flight every day of every week that you're taking. That particular flight is late, 7% of the time. Which may or may not be impacted by other flights, but in and of itself, we're going to say it's independent each week. Does that make sense? Okay. So, I want to know what is the probability over a month. We're going to make the assumption that a month is 4 weeks. I know it's
So
not
20
quite.
days, not so like 20 work days.
So there's 4 Mondays. Okay? So there's 4 Mondays over a month. Okay? What is the probability that you were late every time? What's the probability that the flight took off late every time over a month? So that would be you were late, and you were late, and you were late, and you were late.
And then you were fired.
2.4 times 10 to the negative fifth. Am I late?
Is that the answer?
Is it?
What did you do?
I did 0.07 to the fourth.
Yeah. So you're going to do 0.07 times 0.07 times 0.07 times 0.07, and what do you get, Sarah?
2.4 times 10 to the negative fifth.
1, 2, 3, 4, 2 point something? Is that what you said?
Yeah. 2.401.
Okay. All right. So not real likely, right? If it's only late 7% of the time, you wouldn't expect it to be late four times in the month. Okay? So that's not real likely to happen. Okay. What's the probability that you are late at least once? Now, in order to do that forward, I would have to do that I was late 1 time. I would have to do that I was late twice, and twice could have happened the 1st and 2nd week, the 1st and 3rd week, the 1st and 4th week. I'd have to do all those different cases. Then I'd have to do 3 times, and then I'd have to do 4 times. So it's much, much easier to do this, okay? Because being late at least once is the complement of never being late. So it's a lot easier to do, what's the probability that I'm never late? So what's the probability of not being late?
1 minus.
Well, no, yeah, which is, what's
0.93.
not 0.93, and then that I wasn't late, and then that I wasn't late, and then that I wasn't late.
So 1 minus 0.748.
Is this 748?
Yeah.
Okay. All right. And by the way, what's the easy way to do 0.93 times 0.93 times 0.93 times 0.93?
Negative fourth.
Yes, exactly. So that's 0.748 So I do 1 minus that,
0.2519.
so 252, right? So 25% chance that at least one of those 4 times I'm going to have a late flight.
Gotcha.
Okay?
That's fairly high, I don't know.
That's pretty high, you know, but it's because you're combining all of them. It's because you could have been late once, you could have been late twice, lots of different ways, you could have been late 3 times, lots of different ways, and you could have been late 4 times once.
2 were late,
'Cause
3 are late.
that one didn't happen very often, right? But the 2s and the 1s are gonna happen reasonably. Because you could have been late, the first one could have been late,
First one, that just messes
or
with
the
it
second
all.
one, or the third one, or the 4th one. So you actually have 4 times the probability of one late one. Okay, now, let's just fly twice. Okay? What is the probability that I'm on time both times?
.865.
And what did you do?
0.93 times 0.93.
Good. So 0.93 squared, 0.8.
6.5.
Good. Okay. So the probability that I'm on time both times is that. What's the probability that I'm late both times?
.0049.
Hold on, 1 second.
Which is 0.07 squared, right?
Oh,
Okay. Now, what's the probability I'm late once and on time once?
.0651.
How'd you get it?
I did it wrong. 0.93 times 0.07.
Okay. So Sarah did 0.93 on time times late, which is what?
0.0651.
0.651. Now, if that's all my options, right, they should add up to 1, do they?
we just made the tree happen.
Kind of.
It's not all options.
That's not all our options.
Oh, fiddlesticks.
It doesn't add up to 1. Okay, Sarah just did, I was on time, I was late. But I have another option here. In that order. So what's my other option, Robbie?
On time and then late.
Exactly. I have to do the other option, which is that I'm late and then on time, which is also 0.0651, right?
So if you just, so you just have to add.
You just have to double it. They'll always be the same probabilities. You just have to double it. So 1301, is that right? Did I add right?
Yeah.
Okay. Now if you add up all of them,
That makes, because I
It
knew I did
works.
something wrong.
okay? And Jacob said, you just made a tree. Was it you or Robbie? Somebody just said, yeah, you just made a tree, and I did. On time, late, right? 0.93, 0.07. On time, late. On time, late. 0.93, 0.07. 0.93, 0.07. 2 lates, 2 on times, but there's 2 different ways to be one of each, and you have to account for them both.
Okay.
Okay?
That makes sense.
Make sense?
I
It's all
understand it
coming
now.
together.
This makes
Good.
So
The
does
world
one
is making
minus
sense.
none not work in this situation?
If I asked you, here's where 1 minus none works. If I said, what is the probability that you were late at least once?
Oh, probably.
Okay, then I could do 1 minus this, because at least once would include late both times, and the 2 different weights I could have been late once. So it would have been, I would have gotten rid of this one, and this one, and just used that one, right? And then done 1 minus that.
Yeah.
And it would have given me the other 3. Now, if I only have 2 options, it's not so bad to do 3 different cases.
Not really, no.
But it's horrendous to do them if I want 10 or 12 or 8 different ways.
Yeah.
Even the 4 was going to get